Now we will see a typical problem to draw the ellipse. Note down that problem. The distance between directrix, we can say D1 directrix is 150 mm, and the distance between two vertices are 100 mm, V1 100 mm. Draw the ellipse. Here distance between directrix is given. See, this is one directrix and distance from this directrix to other, that is equal to 150 mm. This is the other directrix. This is D. This is D1. D1 is equal to 150 mm. Now, V1. Now, we need to look at the midpoint. This is O. Here to here 75, 75. Distance between vertices, that is equal to 100 mm. Okay? Therefore, O2 here 50. This is V. O2 here, this one. This is V1. Okay? Now, which method we need to adapt, that is not given. And which method we need to follow, or how we need to follow the method or anything, it is not given in the problem. We need to decide. Here, directly either oblong method or either eccentricity method or concentric circles method, we cannot adapt directly here, right? Now, for this, one observation I will explain from the eccentricity method. First, we need to do one observation. Here, see, in the eccentricity method, first we draw directrix and position of the focus F. This distance is given in the problem. After that, we locate the position of V based on eccentricity. Okay? After that, we draw the vertical line. V as center, VF as radius. We draw like this. Right? After that, we draw a proportionate line. Suppose this is the center point of ellipse, okay, or intersecting point of major axis and minor axis. Here we consider number of vertical lines randomly, and suppose if it is 1, 1 dash, 2, 2 dash, 1, 1 dash as radius, F as center, we draw the arcs either sides. Here also 2, 2 dash as radius, F as center, we draw the arcs either sides. Okay? Likewise, we consider number of lines. After that, we look at these points, we draw the smooth curve. To find the end point, what we did from the end point, from F, we draw a 45 degrees line, and we'll identify the intersecting point with the proportionate line. After that, we draw a vertical line that gives us other end of the major axis. Okay, so that the length we can find. Now, we concentrate our idea on the minor axis. Suppose this is the center point or intersecting point of major axis and minor axis, right? Now consider a vertical line here. Let it be C. Suppose if you want to locate the position of minor axis end, OC is the radius, F as center, we need to draw an arc on either sides. Right? OC as radius, F as center. See, we draw like this. Right. And this is the point on the profile of the ellipse. Obviously, it will be end point of minor axis. Okay. From the property of ellipse, see, this is the ellipse and this is F1 and this is F2. If you consider C end point of minor axis and if you draw a line, this line length CF1 is equal to semi-major axis, that is OA. Okay? Now we observe the properties of ellipse. Here the property is this CF1 is equal to semi-major axis, right? And at the same time here this CF1 is considered from OC dash. That means this is equal to semi-major axis and OC1 or OC dash is equal to semi-major axis. Okay, this OV also equal to semi-major axis. Okay, that means OV. CF1 is equal to CF1 equal to OA, OA equal to OC dash, and OC dash is equal to OV. Right? Now, this OV equal to this OC dash and this is 90 degrees. Now, if we draw a line in between these 2 points, the angle will be 45 degrees. Okay? Now, using this property, we can finish this. Now, come here. Already, what is semi-major axis? We know. And position of V, we know. From here, with 45 degrees, draw a line. Okay, this is 45 degrees. Okay, we got this point. Okay, that point is nothing but C dash. Okay. Now, D, C dash. These two we know. Now, we can draw the proportionate line. Once you draw the proportionate line, from V, draw a perpendicular line. Right? Now, V as center, this point, V dash as radius, rotate like this. Now, this point is nothing but F. Okay? Once you got F, this OC or semi-major axis as radius, F as center, if you draw an arc, see, this one, and F as center, we need to draw arcs either sides, right? Now, if you draw arc here and here, Okay, this will give us minor axis length. We know the major axis, we know the minor axis. Now we can adopt any method and we can draw the respective ellipse. Okay, and already 50% of this is similar to eccentricity method. That is the reason we can consider vertical lines. Okay, and give the numbering as 1, 2, 3, 4, and here it is 1 dash, 2 dash, 3 dash, and 4 dash. Okay, 1 dash as radius, F as center, draw arcs on either sides. Okay, next 2 dash as radius, F as center, draw arcs on either sides. Right. Next 3 dash as radius, F as center, draw arcs. Next 4 dash as radius, F as center, draw arcs. Right. Now draw a smooth curve through all these points. Okay, now the required ellipse is obtained. If we take the exact dimensions, the curve will be exact. Here, see. Here through F I draw, but we need to draw through V. The curve will be perfect if we take the exact dimensions. Okay.